Read the question carefully. Here it says you owe 1500 on the credit card that charges 1.5% interest rate each month. You pay $120 each month and you make no new charges. When will the account be paid off? Pretty much how many months? How much is the last payment? So the initial balance, let's say AN be the balance at each month. So the initial balance A0 is 1500. Okay, we know that 1.5% is what? In decimals, 1.5% divide by 100, 0.015. Okay, so AN is the monthly balance. Then the balance in the next month, AN plus 1, is the balance in the previous month, AN plus interest earned, 0.015. So 1 plus 0.015, that is 1.015 of AN, and minus, so you pay $120 each month. Okay, so this is the dynamical system we have, and we know that when a system AN plus 1 equals R AN plus B, then the solution AN is C R raised to N plus B over 1 minus R, where C depends on initial value. Here A naught 1500. Okay, so from this one now we can write down the solution, that is the balance at each month, and at the nth month, n could be 1 2 3 4. The balance is given by C. R is this number, 1.015 raised to N plus B over 1 minus R. B is negative 120. B over 1 minus R. R is 1.015. So 1 minus 1.015 is negative 0.015. Okay, let's simplify. So AN equals C 1.015 raised to N. So divide 120 by 0.015. So we get 8,000. Now we need to determine the value of C, for we use the initial balance using A naught when N is 0, 1500. Okay, so this is 1500 when N equals 0. C, a number raised to 0. Any number raised to 0 is 1 plus 8,000. Subtract 8,000 from both sides. We get 1500 minus 8,000, negative 6,500. So thus we have the solution here now. Okay, so let me put up here. So go back here. Thus the solution AN equals C, so negative 6,500 times 1.015 raised to N, okay, plus 8,000. So this is the balance at nth month. Okay, so that's the balance of the credit card at the nth month. Okay, now we want this balance to be 0. When? So set the balance AN equals 0 and find the N, that's the month, because we have monthly payments. So AN is 0, negative 6,500 times 1.015 raised to N plus 8,000. Now we solve for N. So subtract 8,000 from both sides. negative 8000 equals negative 6500, 1.015 raised to n. Here is a times, so we need to divide both sides by negative 6500. So negative 8000 divided by negative 6500 equals 1.015 raised to n. Okay, now our n is in the exponent, so we need to take natural log to get rid of this n or bring n to the bottom. So negative cancel. We can also cancel two zeros, so take ln both sides. So ln of 80 over 65 equals, when you take natural log, this n jumps to the front, n natural log of 0.015. Okay, now n times, so divide by this natural log, we get n. So n equals natural log of 80 over 65, everything divided by natural log of 0.015. Okay, use your calculator. So this is 1 point, my bad, it's a mistake here. So 1.015. Okay, and use your calculator. It comes out to be about 13.9. So it's a 13 and almost 14th payment will be 0, and it won't be the 120. I mean, we are paying 100, you are paying 120, the last payment will be less than that. So that means how many payments? So 14 payments. Okay, and the last payment amount will be, we want to find the balance after 13th payment. So A13. Okay, we have to go back, and here is the solution. Plug in 13. Okay, that's the balance left after 13th payment. So we need 13.9 payment, that means 14 payments, okay, to get the balance to 0. But the last payment won't be 120. Then we want to find the balance left after 13th payment. So let's find A13. That's negative 6500 times 1.015 raised to 13 plus 8000. Now use your calculator. It comes out to be about 111.91 dollars. Okay, that's the final, that's the, in fact, last payment. That's the balance on 13 after 13 payment. So this will be the last payment, 111.91, final